Hello, good day, class. How are you? So I hope you're okay. Let's start with our topic today, which is Introduction to Probability. So these are the following objectives. We're going to calculate the probability of the simple events. We're going to learn how to analyze simple probability and to be able to determine the probability of the simple events. So these are the following objectives. But before that, as you can see, the background, we have the question mark. So it's because if we are talking about probability, have you heard about the current or recently lottery result in which we had um, how many? We had 400 plus winners of the lotto. Wait, hold on. Okay, this one. So as you can see, 433 people won a 400 million lottery. So the question there, was it pure luck? Okay, so there are lots of conspiracies about this. If this is a fraud or So, but of course, a believer of the science, especially in mathematics, okay, as a math and as a math teacher, as a math professor, as everything is possible. So that is why if you're talking about probability, there's always uncertainty. Okay, so that is why. So if you're going to simply define what is probability, this is simple. The degree of uncertainty, which is we call it probability. So anything could happen. So just in case, not just marites. Okay. So again, probability, when you're talking about probability, it is just simply uncertainty because we don't know what's gonna happen. Okay. So we're going to, anyway, define the following terms. We have probability, experiment, sample space, and events. So we already defined probability. Well, experiment, this is determined by the probability. So your probability is determined by the experiment. Okay, so for example, we have a toss coin, okay, of money, so which is actually the probability of having this is 50-50. So we could only have either heads or tail. So another is interviewing voters to determine whether the preference of political candidates. So as you can see the pictures here, so the previous presidential elections, we already have the president, which is Bongbong Marcos. So the probability of Bongbong Marcos to win this is 1 out of 10. So that is just, for example, for simple probability. But if you're going to say, for example, okay, who are the top four presidential candidates here, that what is the probability of winning, okay, with these four candidates? Let's say, for example, the top four lang. Let's say we have Bongbong Marcos, who else? Lenny Robredo, Manny Pacquiao, and I think Isko Moreno. So, if we're going to use them, so four top, most top lang, so that means 4 over 10. So that is the probability, or you can actually simplify that into 4 out of 10, so divided by 2, that is 2 over 5, or 2/5. Okay? So another example, we have here drawing a card from a standard deck of 52 cards. So one deck, of course, that is actually we have 52 cards. So all the possible outcomes of the experiments, we call that sample space. So also remember, when we are asking for the sample space, those are the least of all the possible outcomes. So just like for the toss coins, we have two. Okay, for the list of the candidates last presidential elections, we have 10. So that those are the sample space. And for the deck of cards, so we have here 52 cards. Okay, so next. So an event is one or more outcomes of the experiment. So and that is how many times we perform the experiments, we call that event. Okay, again, an event is it could be one or more outcomes of the experiment. So that means the experiment is how many times we perform the experiment, we call that event. Okay, so The experiment of rolling, so for example, experiment of rolling a 6 dice cube, describing, let's say for example, below, we have here the number, if the number is even, so that means for one dice only, huh? So we have here the possibility, the list of all possible outcomes, which is we call it sample size. So we have here 2, 4, and 6. And then if the number is a multiple of 3, okay, for one dice only, we have 3 and 6. Okay. But if ever we're going to have, let's say, 2 dice, and then we're going to have this numbers of multiple of 3, then supposedly we can have also here 9 and 12, because the maximum number of dice is 6. So 6 plus 6, that is 12. So a multiple of 3 is divisible by 12 is divisible by 3. So then your 9 and 12 here is included. Okay. So the number, say for example, if again, if the number is now less than 10, so for one dice only, so of course, all the sample space here is listed. So that means 1, 2, 3, 4, and 5 and 6. Okay. So theoretically, this is the probability formula of the event. So the number, our numerator here is the numbers of favorable outcomes. Okay. While our denominator here is the numbers of all the possible outcomes. Okay. So a probability of an event is a number of 0 and 1. Okay, that tells how it is likely that is the outcome will going to happen. Now, if the probability of 0, this means that the event is really impossible. And if the probability is 1, that means the event must going to happen. So, for example, how to calculate the probability of a simple event? Let's say we have here a spinner in our right side. This is colored. Okay, red 1 and 3 and green 2 and 4. And then we have here an arrow, so which is actually it's going to spin. So if the spinner spun, okay, let's say assume once, then and this is actually let's just assume that it does not come to rest. So the question, we have a questions here. We have what is the sample space. Of course, that is very basic, so we can see all the list of the possible outcomes. We only have 1, 2, 3, and 4. And then second here, list the outcomes of the spinner if the points to if the points okay if the spinner spawns, then it points to an odd number. So we have here 1 and 3 only. Okay. So if we're going to list the outcomes, if the spinner points to an even number, so we only have 2 and 4. Okay. So, well, of course, if we're talking about probability, then of course, if the outcomes of the spinner were points to odd numbers, so that is 1 and 3, so we have 2, 1 and 3. So 2 over, so the total number list of the outcomes, we have 4, so that is 2 over 4, so that is actually 1/2 or 50%. So the same with the odds or even, so they're just the same. Okay. So another example, we have here 2 dice are rolled at once. So we're going to calculate the probability that the sum of the numbers on the 2 dice is 7. Okay. So as you can see here, the dice, okay, if we're going to assume, we're going to list all the possible outcomes, of course. So the dice we have here 1, 2, 3, 4, 5, 6, 7. So we can pair your 1 with 6, of course, that is equal to 7. Pair your 2 with 5, that is 7 also. And your 3 with 4, vice versa, 4 and 3. Okay, reverse of your 2 and 5, that is 5 and 2, and 7 and 6 and 1 also. So as you can see, if we're going to call it manually, we have 1 pair, 2, 3, 4, 5, and 6. So we have 6. Okay. So if you're going to calculate the probability of the event, this is just simply as the list of the possible outcomes. So we have 6 over. So we have here, since we have 2 dice, so That is 6 times 6. Okay, our denominator here is 6 times 6 because we have 2 dice, so that is 36. So that is why we have 6, our numerator, as the list of all the possible outcomes for 7. Okay, over we have 2 dice, so this is 6 times 6, that is 36. So to simplify this, this is equals to 1 over 6. Okay, and that is the probability. So the probability of the sum of 7 is just simply as 1 over 6. Or you may just simply this also, yes, you may um, express this into decimal or percentage. Okay, next, last example. So we have here exercises. So a coin, if a coin toss 4 times, then we're going to list all the possible outcomes of the experiment as a sample space. Second, we have 2 dice a row. Find the probability of the given outcomes of the following. A, the sum of dots on upward faces is 5 but flat na. Okay. So second, we have the sum of dots of the upward faces is 15. Okay. We will see. Okay, if there are 50, if there is 15. Okay. C, if the sum of the dots upward faces is less than 15. Okay, and if the sum, E. Okay, the sum of the dots on the upward face is 2. Okay. So third here, last we have here, which has the greater probability? So which is either we're going to draw jack, queen, or king from a deck of cards, or drawing a spade. So we have two options here: the jack, queen, king, and then or a spade only. Okay, so let's answer this. So a coin is chose 4 times, so we're going to list all of the possible outcomes. So simply we can actually just manual list all the possible outcomes. So as you can see, we have here first, so this is head, 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 and we have here head, 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 tail. We also have your head, head, tail, head. We have your head, head, tail, tail. Okay. So, we can actually relate these numbers into binary. Let's say, for example, hold on. We will have paint so that I can explain this properly. Okay. So to do this list, so okay, so for example, okay, so we can just simply, our head is 1 and then our tail is 0. So in computers or in numbers or no IT, so anyway, you will learn this later on. So as you can see, we can have here, so list of all the possible outcomes. So we have here, actually I can just simply, because I know the numbers, so we have here 1 2 3 4 5 6 7 8. Let's just say, for example, 9 10 11 12 13 14 15. Now in binary numbers, I will start with 0 here. So my 0 is actually, let's just say, for example, tail, tail, tail. So I can have here, okay, T, 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 and T. So that means we have here 0 0 0 0. Okay, so that is in binary, actually, how to count in binary. So next, for my 1, that is just simply, I have here T, 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 and H. Or this can be converted as 0 0 0 1. That is how we're going to read binary numbers. Okay, so for 2 we have here T, T, this is now H, and this is T. Okay, or this can be converted into binary such as 0 0 1 0. So in binary numbers, this is your 1 0 here, this is read as 2. Okay, while your 3 here, this is T, T, H. Okay, this is 2 plus 1. So this is 0 0 1 and 1, and so on and so forth until such time it will reach, okay, let's say you're 15 here, this is actually now H, 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 It's because the binary reading of the numbers here, this is actually 1, this is 2, this is 4, and this is 8. So if you're going to add 1 plus 2 plus 4 and plus 8, this is 8, 12 plus 2, this is 14 plus 1, that is 15, this is equals to 15. So that is why the conversion here is this 1, 1, 1, 1, in which is this is 15. Okay, that is how you're going to list of all the possible outcomes using binary numbers. Okay, so I hope you understand that. But anyway, you can actually um, manually, manually input this answer. So these are the following answers of our list of all possible outcomes. Okay, so as you can see. Okay, so next, um, second. So we have 16 actually, we have 16 here, 16 list of the possible outcomes. Okay, number 2, 2 days a row. Okay, find the probability. Okay, for number 1, the sum of the dots upward faces is 5. So actually, we can pair this with our 1 and 4 dice. Okay, dice, because we have 2 dice man. Okay, 1 and 4, 2 and 3, or 3 and 2, and 4 and 1. So the list of the possible outcomes here, we have 4, 1 and 4, 2, 3, 3, 2, and 4, 1. So we have 4 divided by, because we have 2 dice, so we have your 6 times 6, so that is 36, so that is 4 over 36, and which is equals to 1 over 9. Or the answer here, okay, the sum of the dots upward faces, so the probability of the given outcome is just simply as 1 over 9. Now, for the sum of the dots of the upward faces is equal to 15, this is actually impossible. So that is why the answer here is 0. Why man? Because the maximum number of each dice, we have 6. So we have 2 dice. That is actually the maximum number of sum that we can have for 2 dice is only 12. So we can even have 13, or we can even have 14. How much more? 15. Okay? So next, letter C. The sum of the dots of the upward faces is 15. Okay? Less than 15. So if less than 15, so we can have all of the possible. So from, okay, 1, 2, 3, 4, 5, 6, and reverse. Okay? 6, 5, 4, 3, 2, 1. Okay, and a combination of them. So this is just simply as, okay, because there are 2 dice, so we're going to multiply 6 times 6 and over the list of all possible outcomes. That is just the same as 6 times 6, so that is 36. So that means the sum of all the possible outcomes when the upward faces is less than 15 is that those all possible outcomes of the probability, which is actually just simply is equal to 1. Okay. So next, if the sum of the dots of the upward faces is 2, so we can have, of course, we don't have any other, even if you're going to reverse this, just the same as 1 and 1. Okay, so 1 and 1, okay, or 1 over 36, because we have 2 dice, so we have 6 times 6, so that is 36, 1 over 36, so this is the final answer. Okay, now, last question we have here, which has the greater probability? So drawing a jack, queen, or king, or okay, drawing a spade. So as you can see, we're going to we calculate our jack, queen, and queen. The result is 0.23. That's actually because we have 3, diba? So we have jack is the first one, queen is the second one, king is the third one. So now we have 4 jacks, we have 4 queen, and we have 4 king. So that is why we multiply 3 times 4, that is 12. And of course, in a deck of cards, we have 52. So that is why 12 over 52. Or simply to simplify this is equal to 3 over 13. Or the answer for the probability of the jack, queen, and king, drawing of jack, queen, or king, we have here 0.23. Okay. And last, we have here for spade. So, there are 13 spade. Diba? So, ay labot si Joker. Okay? So, there are 13 spade divided by the list of all possible cards. Okay, outcomes, we have 52 in the deck of cards. So, 13 over 52, or this is actually just simply as 1 over 4, 1/4, or this is 0.25, or that's 25%. So, 25% for spade, or we have 23% for jack, queen, and king. So, therefore, drawing a spade has a greater probability. Okay? And that's it for our introduction to probability. Thank you.